Of course, many schemes has both numerical dissipation and dispersion. For example, if a lot of people are not happy with this, right? I mean, you get all these high frequency oscillations that is traveling everywhere. So how about a second order scheme that doesn't suffer from all these oscillations? Any suggestions? Yes? How about I upwind but use 2 points upwind? Right? So another way to approximate this differential equation is to, instead of use I plus 1, I and I minus 1, what if I represent it as dui dt plus a combination of something divided by delta x of a times ui plus b times ui minus 1 plus c times ui minus 2. Okay, so I can still make the second order because I still have 3 equations to play with. Okay, so here let's see how do we get the second order. Ui is equal to ui, right? Ui minus 1 is equal to ui minus delta x times u prime plus half of delta x squared plus u double prime, and we can only hope to cancel this. But for the purpose of modified equation analysis, let's actually add another term, which is actually minus delta x cubed u third derivative, and let's even expand further, delta x to the fourth u quad, right? Okay, so the blue terms are not necessary to actually derive the scheme, but they are necessary in figuring out what the modified equation is going to be. So we are also going to be doing the same for ui minus 2 is equal to ui minus 2 delta x u prime plus 2 delta x squared u double prime, right? Because 2 delta x squared is going to be 4, cancels with the 2. And again, we have the terms that we need for modified equation analysis. So we have 8 over 6 delta x cubed, 16 over 24 delta x to the fourth. This is actually cubed, right? Okay, so first of all, let's derive the scheme. The scheme is basically adding, multiplying a on top of this, and b on this, and c on this, and tries to cancel this term, and we should get delta x times 1 over here, and we should get 0 over here, right? So let's plug this system into MATLAB and figure out what is a, b, and c. Okay. Somehow my system is very slow. Okay, so the equations are, let's just put in the terms. The first line is 1, 1, 0, 0. The second line is 1 minus 1 and half. The third line is 1 minus 2 and 2, right? So we want to have this matrix left multiplied with a, b, and c, right? And to obtain a 0, 1, 0. So instead of having left solve, I think MATLAB left solve is this, right? Not completely sure. Let's try 0, 1, 0. Yes. Wait. That doesn't seem to be what I wanted. This is obviously not true because minus 1 times minus 1 plus minus 2 times minus 2 is not equal to 1. So let me do the way I know how to do, which is transposing the matrix and backslash the transpose of this. Yeah, which gets us the correct answer. So basically, transposing the matrix makes our solution to be basically the transpose of this matrix right multiplied with a, b, and c has to equal to 0, 1, and 0. Right. Okay, so this is our scheme. Our A is equal to 3 over 2, B is equal to minus 2, and C is equal to half. All right, so this is our scheme. And now let's plug these coefficients into the blue terms to figure out what is the modified equation. So the modified equation is copying this term plus, instead of writing the numerical scheme, let's write out the expanded terms. So first we have the correct approximation, which is du dx. But then we have everything over here, right, multiplied by a, b, and c. So let's figure out what this is. So b is minus 2. So the first term is multiplied by minus 2, and the term is multiplied by half. So multiplied by minus 2 is actually 1/3, and this multiplied by half is minus 4/6, right? Which is actually 2/3 times delta x cubed u third prime divided by delta x, which comes out to be minus 3 over delta x squared u third prime. So okay, so let's copy this over here. So what term is this? This numerical dissipation or dispersion? Dispersion, right? So it's a odd derivative. And last we have this, this multiplied by minus 2, we get minus 1/12, and this gets multiplied by half, which is plus 8/24. Okay, so this which is what, 4/12, it's 3/12, which is 1/4 times delta x to the 4th u quad prime divided by delta x. So this turned out to be let's see, it's actually plus, right, delta x cubed delta x cubed u quad prime equal to 0. So what is this? What effect is this term? Numerical dissipation, right? But interesting thing is that the sign of this is different from the numerical dissipation we get when analyzing the first order derivative term. The first order derivative term is plus sign on the right hand side. Here, the fourth derivative is plus sign on the left hand side. Why is that? That's right. That's right. So when you do the Fourier analysis, if you plug in u is equal to a sinusoidal oscillation of space, and then you take fourth order derivative, I mean this I actually gets rotated three times. So you actually comes out to be a positive sign as opposed to a negative sign in the second order derivative. Okay, so this is actually the correct sign to provide you dissipation. If you see a positive fourth order derivative on the right hand side, you actually have divergence. Your scheme is going to blow up. Okay, so basically this is a scheme that has both numerical dissipation and dispersion.